that just isn't, it's not possible to get a reliable test that way. And we've done lots of retests showing that results from laboratories claiming that were incorrect, and we can't emphasize too strongly that really is just a consumer fraud, and people do not want to get fooled by the claim that they can do a prenatal test from the mother's blood.
Is something like that addressed by the American Association of Blood Banks?
Yes. No laboratory who's accredited by the AABB could even pretend or claim to do that kind of a test.
Can we talk a little bit about the testing results and how they look? When you deliver a testing result, let's say that it's to the father, who you believe to be the father.
Right.
What result are they receiving?
They're receiving a laboratory report that shows these DNA pieces, these allele sizes we've talked about, and how they match or don't match between the mother, child, and alleged father. And then they'll get a conclusion at the bottom of the report that will be stated two different ways. One is called a probability of paternity, and the other is a combined paternity index. The probability of paternity is only required to be 99%. People get a little bit confused because they see 99% and DNA, and they're thinking, you know, this must be O.J. Simpson kind of numbers. This must be 1 in millions, and I'm sure the dad. But in fact, for paternity, a 99% means we've identified a pattern that the child obtained from the child's biological father. The tested man has it, but on average, 1 in every 100 guys out there has it, and that's just an average. There could be a lot more guys than that. So there's thousands and thousands of guys who have not been excluded yet. And at that level of testing, it's easier to get what they call a false inclusion, where the gentleman's matching, but he just happens to be one of the other people in the population with that pattern. When they do receive the report, we just encourage people to look for a laboratory that will guarantee a minimum of a 99.99% probability of paternity, which would be on average a pattern that fits 1 in 10,000.
And the other result that they get is once again, what was that called?
It's called a combined paternity index, and it relates to a number of different things, including how common this pattern is in the population. But it's very technical, and it's not, someone who's a layperson would not be able really to know what it means just by looking at the number. So everyone focuses on that probability of paternity.
Okay.
Good. In fact, I just want to come in here for a second. In fact, the larger the number, though, the more accurate the test, the more reliable the test. So that combined paternity index, it's very important for it to be a large number. You don't want it to be 101 or 110. You want it to be, you know, preferably in the tens of thousands or hundreds of thousands or millions. You should always be looking for a large number there. And what it literally means is that man is that many times more likely to be the father than a random man is to be the father. So it's a very technical term, and it's hard to understand. But I think it is pretty clear that if you want to be many, many, many more times more likely to be the father than for just to be a random man matching the child.
I have seen from a couple of clients, I've seen something that has appeared on a paternity test that'll say something to the effect of 1 in 500,000. Is that the number we're now talking about? That's the index that we're now looking at. Is that correct?
That's the combined paternity index, yes.
Okay. Okay. So the larger that number is, the 1 in, you know, blank, we want that blank to be as large as possible, correct?
Yeah, it's not actually a 1 in number. That's a forensic calculation. For a paternity calculation, it'll be that many to 1. So the report might say 500,000 to 1, but it doesn't literally mean that 1 in 500,000 men would match in that case. It means he's 500,000 times more likely to be the father than a random man is to be the father.
Okay. So we're talking about probabilities, we're talking about the number of times more likely he is to be the father. Is there such a thing as a certainty for paternity tests?
In reality, yes, but in scientific terms, no. You know, you can get to a number that's larger than the population of the earth, and you're pretty sure then that he's the father of the child, but you never get to 100%.
Okay, so there would never be a probability of 100%. It would at most be 99.99. Is that accurate?
Well, it could be 99 point, as many nines as you can count. You can keep going. It could be 99.999999999 and so on, but you can't get to 100.
Okay. So the Paternity Testing Corporation, your goal is to hit what?
Our minimum that we will release the test at is 99.99%, and the probability of paternity is actually based on the paternity index. So 100 is 99%, 1,000 is 99.9, 10,000 is 99.99, 100,000 is 99.999, etc. We just stop at 99.999. But if we're reporting a paternity index that's a billion, then it's really, it's 99.9999999, I think.
And Angelyn, when Kim says we stop at 99.999, she means that's all we show on the report. In fact, it may really have many nines to it because our tests are exceptionally strong. We just don't print them all out. And this also raises one other very important point. If you find a paternity laboratory that's claiming 100% accuracy, you know they're not telling you the truth, and you want to take that into account and be very concerned about whatever else they're telling you.
Okay. Now I know that you have some tips regarding legitimate testing sites. Can you share some of those with us?
Certainly. The first thing that's important is just to make sure the laboratory is accredited by the American Association of Blood Banks. You can verify that, for example, by going to their website at www.AABB.org. And but without that, you have no idea what you're getting. And then once you confirm that, you just want to know how strong their tests are, and you can ask them two simple questions. One is, how many DNA locations do they test initially, because they're not going to keep going after that initial test if they hit their minimum. The strongest test out there tests 16 DNA locations initially, and that's what we recommend. Some labs only do 13 or 10 or even 9. But you're going to get the test for basically the same price no matter who you use, so why would you settle for a less reliable test? So we recommend that people find a laboratory that tests 16 DNA locations in their initial test, and then ask them what their minimum guaranteed probability of paternity is. And those are the only questions. We recommend a minimum guaranteed probability of 99.99, but don't let the laboratory just tell you what their average probability of paternity is or what they usually get to, because the client wants to know how strong is the test that he's going to get. And so he wants to know, when are they going to stop testing? If they just get a 99% after their initial battery of testing, do they stop then? He wants to know the minimum guaranteed level of testing, and you want the lab to provide that guarantee even if the mother's not being tested and even if they encounter a mutation. And so you just want to pin them down on that. But those three questions, the AABB accreditation, the number of DNA locations tested, and the minimum guaranteed probability of paternity, will cover most bases and get you to a reliable laboratory.
Are there any statistics out there about false tests? I mean, do those even exist?
No, and laboratories are very, very careful if they have a false test, they don't want anybody else to know about it. They'll do whatever they can to try to claim that they don't have one, rationalize it away, or if they get sued about it, before they settle, they'll make the person sign a gag order so the person can't go talk to anybody about it after they settle. So that's something that's a real big secret in the industry, and it's hard to tie down. But laboratories do have these kind of false tests. We've been aware of many of them, but there's no place you can go to find out exactly how many.
Okay. And in terms of a false test, I think we're really talking about two different scenarios. We're either talking about somebody who's been falsely excluded as the father or falsely included as the father. Is that correct?
Exactly right.
Okay, and the falsely excluded, let's talk about that group. How would that work? How would that happen?
That would be the Miami case, for example, is a good example of that, where the laboratory found two places where the father and the child did not match, and just knew that it was possible, but that the guy really was the dad, but chose not to keep testing because they didn't have to, and they issued a test excluding the biological father.